What we have here is two equal spheres, each of mass 1 kilogram, are travelling in opposite directions with speeds of 2 meters per second and 6 meters per second when they collide directly. The coefficient restitution is 3/4. Find their speeds after impact. Okay, so what I tend to do is I just tend to draw a quick diagram, and then just a little plane here. And then as I do that, go and draw a before and after picture. Is the best way to go about doing this. Okay. There you go. So what we have is our before and after picture. Okay. So let's just fill in the numbers. Okay. So you have two main equations when you're doing this. Your two main equations are your, what's it called, NEL is called Newton's experimental law. This equation only relates to speeds and the coefficient of restitution, which is how much energy is lost during the impact, basically. The second one is PCM, also known as principle of conservation of momentum. Okay. So we're just going to put in our numbers now. So we're going to have this one going at 2, this one's going at 6, and that's 1 kg and 1 kg. And then after the collision, you're going to have the speeds after impact. So we don't know any speeds after impact. So there's a choice of what could happen. If you go backwards and the other one stays going this way, you could also have that they're you could have one of them that's going this way, then the other one has to go that way, or one of them could stop and the other one has to go backwards. With all the questions, no matter what they do, always have them pointing to the right. What will happen if it's actually going to the left? Anybody know? Negative. It's just a negative answer. Okay, so you can call them what you want. I'm just going to call them V1 and V2. Just so it stays in line with what's in the equation up here, okay? So, and that's going to be U1, and that's going to be U2. So let's do NEL, Newton's experimental law. So what we're going to get is V1 minus V2, which is this here, over 6 minus 2, oh sorry, 2 minus 6, excuse me, equals minus E, which is minus 3/4. So that's going to be minus 4 times 2 minus 6 being minus 4. And then you're going to have minus 4, cross multiply that up by the minus 3/4. And you're just going to get 3. So V1 minus V2 equals 3. Okay. Next thing we're going to do is PCM, principle of conservation of momentum. So just make this a bit smaller now. Okay, so M1, anybody know what M1 is, guys? M1 is 1 kilogram, M2 is 1 kilogram. So fill in the principle of conservation of momentum. You can label it PCM in your exam. Examiners will be happy about that to know where it comes from, okay? So M1 is going to be 1, U1 is going to be 2, plus M2, which is 1. Plus 6 equals 1 times V1 plus 1 times V2, and long story short, we're going to get V1 plus V2 ends up to be equal to oh, one thing I made one mistake there. Anybody know my mistake? See the 6? It's gone in the opposite direction, right? Ah, 2 mistakes. Just give me 1 second with this. I always forget this. Okay. See the way that's meant to be U1 minus U2? Yeah? U1 minus U2. U1 minus U2 is actually 2 minus minus 6. Okay? So what it should have been was, it actually should have been 8 on the bottom, as opposed to 4, because they're actually going towards each other. So it was actually 8. and cross multiply up the 8, and we get minus 24 over 4. Sorry, it's plus 8, so minus 24 over 4. Anybody minus 6, right? And then we have phi1 plus phi2. That's going to turn out to be 2. 2 minus 6 minus 4. In these questions, you always end up with a simultaneous equation. Each and every one of these are always done with a simultaneous equation. So you have phi1 minus phi2 equals minus 6. And then phi1 plus phi2 equals minus 4. We're going to have 2 phi1 equals minus 10. Phi1 equals minus 5. As predicted, phi1 is going to the left at minus 5. And then we have to figure out what phi2 is doing. So phi1 minus phi2 equals minus 6. So it's going to be phi1. Sorry, 1 second. So bring phi2 over to your side, bring 6 over, and you're going to get phi2 equals phi1 plus 6. Phi2 equals minus 5 plus 6. Phi2 equals 1. Everybody on board with them at the moment? Alright. Find the magnitude of the impulse imparted to each sphere. How do you do impulse, guys? Anybody remember? Anybody know what impulse is? mv, momentum before minus momentum after, of any of the spheres. So I'll call that sphere A and sphere B. Let's start off with sphere A. Okay, sphere A has a mass of 1. What was its final velocity? It was minus 5, yeah? It was going 5 in the opposite direction. And then its initial velocity was 2. So therefore its impulse is going to be 7 kilograms ms to the minus 1. That's for the projectile A. Or not projectile, particle. That's for particle A. For particle B, it would have been 1 times. It was going 6 to the left, which is minus 6. And then it was going 1 to the right. And once again, that's going to turn into minus 7. And because you have to take the positive value, they're both 7 kilograms meters per second. Sorry, the 6 was a starting velocity, so excuse me, so that actually has to be minus 6 here. And that's going to be 1 there. And that just gets you 7 as well. Okay, so 7 either way. Okay, good spot though. Next part of the question. The percentage loss in kinetic energy. Anybody want to take a go at this? 3/4. Let's see if that number comes up again, okay? So, percentage loss in kinetic energy, okay? So, you're going to compare percentage loss in kinetic energy. Anybody know the formula for that? Kinetic energy before minus kinetic energy after. That will get you your loss in kinetic energy. Okay? And what's it going to be all divided by?
Kinetic energy.
Kinetic energy before. And does it say percentage? So what does that mean at the end? Times 100 over 1. Okay? So just even putting down that formula just sets everything off. So kinetic energy before is a half. It's all a half mv squared, but we have to find out what the mass is. So a half 1. What was your velocity before? Now there was 2 different parts, wasn't there? So each one had each one had 2 different parts. So what we'll do is we'll just compartmentalize it and just do each part individually, okay, just to make things a bit easier. So K before is a half 1. What was particle 1? A half 1 times 2 squared plus a half 1 times minus 6 squared. Add them together, we'll get 2 plus 18, yeah? 20 joules. Kinetic energy after? What was it? A half, 1 times, that one went off at minus 5, didn't it? Minus 5 squared. And the other one? A half, 1 times, minus 1 squared. And what do we get? 13.5? Is it?
No, 13.
12.5, oh yeah, sorry, you're right, 12.5 plus a half is 13. Yeah, thanks. Now, your loss in kinetic energy. So your loss in kinetic energy is 7 joules. You divide that by your 20 joules and you multiply it by 100 over 1. And what do we get?
35%.
35%. Is that the answer in the solutions?